Hey, thanks so much for joining. I'm Joe Peterson. I am the Chief Analyst at ClearTech Research, and I'm here today with your news you can use from the 843 Big Tech Report, and this is our Tech Bite on CNAAP. So today we're going to talk about CNAAP use case and the use of AI and ML in CNAAP. So let's take a step back first. The move to the cloud posed two challenges, and one of the simplest ways attackers can get to an organization's crown jewels in the cloud is by clearing attack paths through a combination of network access and permissions. In what's quickly becoming a go-to method, many attackers use cloud-native privilege escalation techniques like PassRole to gain privileged access. The smallest drift in an environment can open up these attack paths in seconds, creating utter madness for business. So with the right privileges, data exfiltration takes mere moments, and it's almost impossible to detect. To expose these types of attack paths, DevOps and security teams can use machine learning capabilities embedded in a cloud-native application protection platform or CNAAP solution to detect abnormal permissions, correlate all the signals, and search for privileges that collide with public exposures and vulnerabilities. One of the problems that frequently bubbles up and one that's difficult to track and catch is extra permissions being granted to users within a single tenant. In these cases, most permissions are unused and attackers can take advantage. So a CNAAP solution can detect abnormal permissions of identities within a tenant using specific machine learning methodologies. So let's take a minute and talk about the definition for abnormal. It is simple. It's actionable plus most risky equals abnormal. For instance, when users in a given group each have more or less the same set of permissions as in an environment, but one user has extra permissions in another environment, we consider the extra permission abnormal. In case of outliers over data that consist of large numbers of features, the native machine learning models would usually be PCA, DBScan, LOF, or isolation forest. We consider that the perfect model is a genetic algorithm. Genetic algorithms aim to detect mutations within a series of genes. So how exactly does that happen? Let's look at a specific example. After more in-depth ML calculations to emulate false positives, you'll end up with a genetic algorithm that can detect outliers without normal permissions. It's fast, simple, and effective. Trying to perform this kind of analysis with a legacy approach would require a massive manual effort to first understand the business impact of each permission and then detect which permissions are excessive. On the other hand, an ML-based approach suggests a self-learning method without the need to understand each and every permission, helping to expedite the process. I hope that's a way that you can see the use of AI and ML occurring in CNAAP. If you like my post, click on the bell on my profile. Follow 843 Big Tech on Twitter. Thanks for joining.